Hi y'all. In this video, we're going to look at parabolas that open right or left. That is, they have a horizontal axis. Specifically, we're approaching this from a conic sections lens, and all of the parabolas in this video will be centered at the origin. So as we derived in a prior video, parabolas of this type have the form y squared equals 4 times p times x. Now, actually, in the other video, I derived the other version for parabolas that open up or down, but it's the same math you could follow to derive this formula. So they all have a vertex at 0, 0. You can shift it. That does change the equation a little bit. They all have what we call the focus, which is an invisible point right here at the point p comma 0. So p is the distance from the vertex to that focus, if the focus is on the right, on the positive x-axis, and p itself is a number which can be negative, so it would be over here if p is negative to the left of the y-axis. So specifically, it's going to open right. These parabolas will open to the right if p is greater than 0. So if p is a positive number, it'll open to the right, and as shown below, it'll open to the left if p is negative or less than 0. Okay, so let's work through an example given the equation of not quite standard form, but it is a parabola centered at the origin. 6x plus y squared is equal to 0. We're going to find the focus and the directrix and sketch a graph, and then we'll also look at how to do this on a graphing calculator because it's a little bit, it involves a little bit of algebra first to do that. So first off, let's put it in standard form. So to do that, we are going to solve that for y squared. So to solve that for y squared, all we need to do is subtract 6x from both sides, and that'll give us y squared is equal to negative 6x. Now the standard form, as we just said, is y squared is equal to 4p times x, where p is some number, which it tells us the distance to the focus and directrix. So what we can do is set these coefficients equal. That coefficient of x will have to equal that coefficient of x, and so we'll get negative 6 is equal to 4 times p. And if we divide both sides of that equation, we'll have negative 6 over 4, which reduces to negative 2/3. I'm going to flip that around, or negative 3/2. So p is equal to negative 3/2. All right, so that then tells us that the focus is to the left. So this thing is going to open left. So if I go by ones, it's not really big here. Right, there's my focus at the point negative 3/2, comma 0. Right in there, I'll put that over here as well. Focus is at negative 3/2, comma 0. And also, we can graph the directrix. Now, the parabola is going to open to the left and it has a vertex at the origin. So it's going to kind of curve up. I'm not going to get too detailed into plotting a whole lot of specific points on this particular video because that's not really the point. But the point is that if we also graph this vertical line, which is the directrix, that is your line x equals to, well, x equals negative p, right, by the formula. But p itself is negative, so therefore those two negatives cancel and we get x equals to 3/2. And that, my friends, is the directrix. And it also goes down. Draw the bottom half right there, okay? And so geometrically, any point on this parabola is equidistant from the focus to that line, the directrix. Those two distances are equal. So there's just a quick hand-drawn sketch, probably not too precise there, but that is completely okay. That is the graph of 6x plus y squared is equal to 0. Now, I'd like to also show you how to do this on a graphing calculator. Specifically, we're going to look at the TI-84 since it is so commonly used. Significantly easier in Desmos, you can just type it in as it's given, 6x plus y squared equals to 0. But in order to type it in on this, we are going to need to solve for y first because as you probably know, it's got a y equals button. I'm going to clear my calculator here. There we go. Get a fresh start. So let's start with the equation again up here. Y squared is equal to 4 times p times x, but I'm going to use the negative 6x version that we've got there. Now to enter that into, My calculator go here. There it is. To enter that into here, there we go. We're going to hit the y equals button, and we're going to have to solve this for y first. Let's get all the buttons on there. There we go. Okay, so we're going to take the square root of both sides of this equation. I'll bring that calculator back in just a moment. But if I take the square root of both sides, we get y is equal to. Now, anytime you take the square root of a variable that is squared, we're going to put a plus or a minus on the other side. So it is technically equal to positive or negative square root of negative 6x. Well, that's really two separate equations, right? One of those equations is y equals the positive square root of negative 6x, negative there, and the other equation is y equals to the negative of the square root of negative 6x. Now, you might be wondering why it's okay to have a negative under the radical. It actually does work because x itself, in this case, is only allowed to be negative. So we're going to find the square root button. There we go. Square root of, use that negative button there, negative 6x. And I can go ahead and graph that. See, it's only giving me the top half. So this equation with the positive root gives you the top half. And then in y2, we're going to put negative square root of negative 6x. And that's going to give us that bottom half. You can see in a different color there, right? So the reason we have to have two separate equations is because this is not a function, right? So we have one y for the top half and different y for the bottom half to get that full graph in the TI-84.